Hey everyone, and thanks for tuning in. So in the second part of our series about async and await, we're going to look at Objective-C interoperability. Why is that important? Well, there is still a lot of Objective-C frameworks and SDKs out there, and Apple wants to make sure that we can use them seamlessly and call any asynchronous code using async and await. Besides, they probably have a lot of Objective-C code as well and want to make sure that we can call it seamlessly. One of the third-party frameworks that makes extensive use of Objective-C is Firebase. In fact, it's largely written in Objective-C, mostly because it's been around for such a long time that we didn't even have Swift when we started writing it. If you don't know what Firebase is, it's Google's mobile platform for building applications for Android, iOS, and the web, and it contains a number of services. So one of the services is Firebase Authentication, and on my screen here, I've got one piece from our API which lets you sign in a user using email and password. So this is an asynchronous operation because you call the method and then it verifies the user's email and password, and then it will return the call. And because this is a client to server call, it might take a little while, right? Even if it's fast. And because it's asynchronous, it needs to be able to call you back when it's finished. And this is what's happening here. So this completion block here, this is essentially a callback that will call back into your code once we have verified that the user is actually a valid user and that the password is correct. And in return, you get an auth result, and in the auth result, there is the user information such as their user ID, their name, their email address, and maybe even their profile picture. Today, we're going to look at how to replace this callback style calling with async and await. So to do that, I've written a little application, which I'm going to walk you through real quick. So we're going to look at three APIs. So first of all, Firebase Authentication, where you can sign in with a variety of authentication methods. For this demo, I've just used email and password because it's the easiest to set up. So I click here, the password was conveniently pre-filled, and then in return, I get the user and their email address. I can sign out again. Then we've got Cloud Functions, which is our serverless product. So I've got two functions running in our backend. One is called Hello World, and it says Hello World from Firebase. And then we've got Hello User, and I can provide a name here. And then as I call it, it will return a personalized message to me. All right, and finally, we've got Cloud Firestore, which is a document-based NoSQL database in the cloud. And in here, I have three buttons, one for fetching my favorites. So my favorite fruit might be apple, and then my favorite number might be 42, and I can change that. So let's say I might rather like mangoes, and then I can go ahead and save that, clear the form, and fetch my favorites again, and it says, your favorite fruit is mango. Right, so let's look at the code. And let me make some space here. So this is all written in Swift UI. So let's look at our sign-in screen here. So you can see that this is a view. I'm using a state object to handle access to Firebase. And here you can see the body, and we're using a form, and so on and so forth. And here you can see that, for example, here I'm binding to the email property on the view model. And further down here, let me find the button. So when I click on the sign-in button, we will call the sign-in method on the view model. So let's quickly go there. And you can see up here in our view model, which is conveniently in the same file, but you could place it in a separate file if you wanted. We call Firebase Authentication, and we use this method that I just showed you in the API documentation, where we call it using our email and password. And then back here, this part, this is the completion block I showed you. And here in Swift, it's implemented as a trailing closure. And here we've got the result and an error. So these are the return values that we get. So if anything went wrong, the error will be non-nil, and we can have a look at that. But everything went well. We can just inspect our result, and we'll get our user. And when we do that, we will assign the user to our property up here. And this is bound to the UI, and it will update the UI. And there is some combine going on here. So I'm using the user as a publisher, and then I have a look at whether the user is non-nil. And if it's non-nil, I enable the sign-in button by toggling the is signed in property up here. All right, so far so good. Let's have a look at how we can actually use async await in this piece of code here. And I'm going to just rename this method here. And in the last video, we saw that in order to call any async await code from the UI, we need to use an @async handler in our code here to make that happen. So let's just do that, @async handler. And then I'm going to insert this method name here. And then I'm going to call the very same method, but no, I'm not going to use the callback, but I'm going to use async await instead. So let's start out by saying await. And then I'm going to say auth.sign-in. And then let me type email. And this filters down our options, and we can see that we still have the signatures which contain the completion block. But up here, you can see that we also have the signature which contains async throws, which is something that we didn't write, and the Firebase team didn't write. But instead, the Swift compiler synthesized, it's a difficult word, synthesized this call for us. So let's fill in the parameters. So up here, we need the email, and then back here, we need the password. And then instead of using a trailing closure, we'll first need to say, OK, this can throw, so we'll need to wrap it in a do try catch block, and then just print the error here. Now we're calling this in a safe manner. But now we want to take the result and operate on it. Let's take the result. Let result equals try await. So we get our authorization result, and that's very much the same as this one down here. And now the compiler says, well, you're not using this. All right, that's right. So let's do that. So we actually want to reach in and check the user and assign it to our user property. So self.user equals result.user. And that's fine. And it does work. However, the compiler will complain, or at runtime, the application will complain that we're trying to modify the UI while we're maybe not on the main thread. So to ensure that we're on the main thread, we're going to use dispatch queue to jump on the main thread. So let me quickly do that. Dispatch queue dot main dot async, and then move this code up there. And this ensures that we're on the main thread while we're modifying this property up here, which is published and is bound to our Swift UI view. OK, so let's quickly have a look if this still works. So just to be sure, I renamed the old method, and this is our new method with the same name. Let's run this. There's our application, and sign in, and voila, there's the user. So this code now makes use of async await, and it works just like before, which is exactly what we wanted. So let's have a quick look at what the difference is. So instead of having this trailing closure, which might be difficult to read, we have a much more linear way of writing this, because we essentially just say, okay, make this call, and then wait until it returns, and then continue with the flow of the application. And you might imagine that we're doing a couple of things here. So we might sign in and then fetch some information from the database based on the sign-in user, and so on and so forth. And you can see how this might be much more elegant than having to use nested closures. All right, so let's now look at the other APIs that I showed you before. So let's first look at Cloud Functions. And again, this is this part of the UI. Again, let's look at the code for the UI. So we've got our functions demo screen, which is a view. We're using a state object, which is our view model. And then we've got the various sections up here. And let's look at this one, which takes the user's name or whatever you enter in this field. And then when the user clicks on the button, it will call hello user on our view model. So here we are. To explain this piece of code, you need to know that hello user, this is a serverless function which runs on Firebase Cloud Functions. And we want to call it using HTTPS and then take the result and display the result in our UI. So what we do is we tell Firebase, hey, we want to call a function with this name, and we get a callable in return, and then we can invoke the method call on this callable, and then pass in any number of parameters. And this function there just takes one parameter, so I'm just passing in the name. And then when it returns, we will first look at the error, and if there is no error, we will look at the result, extract the data object, typecast it as a string, and then assign the result to our message property, which is bound to the UI and will display a sheet. Okay, so let us rewrite this function. So let me first rename this to old, and then use @async handler. And then I can just take this piece of code here, because that will stay the same. And then I'm going to call this hello user callable using await. So await hello user callable.call, and I'm going to pass in the name parameter. And because this can throw, we'll need to call it using try, but it might return nil. So I'll just say try ? And this is unused. So let's assign it to our result. Let result equals try ? await. All right, this is great. And then we want to use that. So let's say if let data equals result.data as maybe a string. And if so, we want to do something with it. So we want to do this. We want to assign this to the message property, and we want to trigger the show results sheet. But again, we need to make sure we're on the main run loop. So dispatch queue .main.async, and then move this in here. Let's run this. And there we are. Hello Swift, call hello user, hello Swift from Firebase using async await. So I'm not going to do that to all the other methods in here, but instead let's have a look at Firestore. for Firestore, we have those two buttons here which fetch and save our favorites. So let me make some space here. Okay, so here we go. We've got save favorites and we've got fetch favorites. Again, these are on our view model. So to explain this piece of the code, so we use Firestore, we navigate into the favorites collection in Firestore, and then we fetch the, we specify the sample document, and then we say, okay, get us this document. And once Firestore returns the document, we get a document snapshot, and then down here we will use Firestore's codable support to map this document, which is, it looks like it's a dictionary, and we will map this onto our favorites struct up here. So favorites struct looks like this. We've got a document ID, which is the ID of the document in Firestore. And then we've got a fruit property and a number property. And thanks to the codable support, we won't have to do the mapping ourselves manually for each single attribute, but Firestore will do that for us by just calling data as. Simple tip. Don't map manually, use codable. Okay, so, but we're not here to talk about codable, we're here to talk about async await. So let me copy this and then rename it, and then let's re-implement it using async await. So add async handler. And then again, we can take this, and you realize I'm not taking the closure, but I am using this, and then let's call it using await. And of course, it can throw. So let's say try await, and then what we get here is a document snapshot. So let's assign that let document equals try await, and so on and so forth. Let's wrap this, and let me actually type document properly. Document cat print error. Okay. Wonderful. So, and then again, we can take this part of the code, insert it here, and then we need to jump onto our main queue, dispatch queue.main.async. And let me see. Oh yeah, this needs to be a document snapshot like this. Okay. All right, so what happens is we make the same call for fetching the document, but this time around using try await. So once this returns, we will get the document snapshot. We will use it to map the document into our favorites struct, then jump on the main queue and assign it to our favorites. Let's run the application once more. Go into Firestore, fetch favorites, and there you go. We've got the same stuff that we stored before. Let's take Apple and then a random number, 1, save favorites. I'm going to clear the form and then fetch the favorites, and there you go. So this works nicely. So to conclude, I think you saw that it's pretty easy to rewrite your callback-driven code and make use of async in the wait. And even with those small samples, it was clear to see that the code is now more readable and it gets into a more linear style. And if you have more calls that depend on each other, this will be a lot more readable. So I'm super excited that this was possible without any extra work. So if you've got any Objective-C frameworks that make use of callbacks, it will be super straightforward for you to make them available for async and await, because you will have to do nothing, right? So it will just work out of the box, which is great. So thanks, Apple. This is really amazing. The one thing, though, that I'd like to mention is that I find it a little bit clunky that we always had to use dispatch-queue.main.async to get back onto the main queue. I don't know if there is any better way to do this. I mean, it's not terrible, but I would love to see if there is a better way. So if you know of a better way, please let me know in the comments or reach out to me on Twitter. If you like this kind of content, let me know by giving a thumbs up, and don't forget to subscribe to the channel. Thanks for watching, and I will see you next time.